In this video, I'll explain what it actually takes to secure a job in machine learning, assuming you are starting from zero. No shortcuts, no hype, just what consistently works in practice. But before we begin, let's briefly revisit what an ML engineer is expected to do. So it will be research and implement appropriate ML algorithms and tools, design and prepare datasets, design and develop machine learning systems, run experiments, evaluate results, and iterate. If you don't like experimentation, debugging and uncertainty, ML is probably not for you, and that's fine. This is the first uncomfortable truth. A degree is not a perfect measure of skill, but in ML, it still matters a lot. The field is heavily influenced by academia. It's common for chief scientists or senior ML leads to be former professors or full-time researchers. They review CVs through that lens. Even for junior ML roles, LinkedIn applicant statistics often show 80% or more candidates with a master's degree, and a noticeable portion with PhDs. Interviewing is expensive, and when a hiring manager has 200 applicants, filtering out those without a degree is an easy and rational decision. Can you succeed without a degree? Yes. Is it the hardest possible path? Also yes. A degree doesn't prove excellence, but it does prove exposure to math, theory, and long-term discipline, and that's necessary to get your CV past the first filter. This is where many ML beginners fall apart in real projects. A large part of ML work is just software engineering, whether people like it or not. Here's a simple test. If a small change, like adding one feature or switching a model, forces you to rewrite your entire pipeline, you don't actually have a pipeline. If you can't reproduce your own results a week later, your experiments are useless. And if other people can't read or understand your code, you won't be able to contribute to the team's work. In practice, ML work means building data pipelines, training and evaluation scripts, configuration files, and experiment tracking. You should be able to prepare your own environment, structure your project, and run experiments reliably on more than just your local machine. You don't need to be a senior software engineer, but you do need solid Python skills. That includes object-oriented programming, writing readable and modular code, and making your experiments reproducible. If your model only works once on your laptop, it's not an ML system, it's a fragile draft. What you actually need at this stage is not mathematical mastery, but understanding the moving parts of machine learning. You should clearly understand how data is represented and passed into a model, what exactly is being optimized and why, how data is transformed as it flows through the model, how models are trained in practice, and what approaches existed before neural networks. In other words, you should know what the model sees, what it changes internally, and what signal tells it whether it's doing a good or bad job. Many candidates can use frameworks, but can't explain what a loss function represents, why gradients exist, and how training actually works. Classical ML still matters. Linear models, decision trees, and SVMs are not obsolete. They are often used as strong baselines, components of larger systems, or even final solutions when the problem or constraints demand it. In many real-world cases, a well-tuned classical model outperforms a complex neural network in terms of stability, interpretability, cost, and time to deployment. Working with classical methods also teaches you when deep learning is unnecessary, which is a critical skill in practice. The goal is to understand the system as a whole. Once you have that mental model, the math and details stop feeling random. YouTube is not education, it's content. The lack of structure is exactly why many people feel stuck after months or even years. Once you have a rough mental model of ML, commit to a structured course and actually finish it. A good example is the deep learning specialization on Coursera. The goal here isn't to become an expert. The goal is to see the full pipeline end to end: data, model, training, evaluation, limitations. You truly understand something only when you can explain it clearly to another person, That's not a motivational quote. It's how it is, and you'll see it already on ML interviews. For example, you might be asked, why overfitting happens? Why adding more data sometimes helps more than changing the model? Or why a simpler baseline beats your complex architecture? If your answer is, because that's what the tutorial did, you are not ready. Resources like StatQuest are excellent for building that intuition-level understanding. Intuition is what lets you reject bad ideas early and defend good ones later. I strongly recommend writing a survey-style paper, especially if you're at a university. This is one of the most efficient ways to level up early. A good survey forces you to understand the current state of the art, familiarize yourself with popular approaches in a field, and see how ideas have evolved over time. You start noticing patterns, what consistently works, what rarely does, and which problems remain unsolved. For example, if you choose object detection and tracking, you'll quickly learn which architectures dominate, which datasets everyone uses, which metrics actually matter, and where the real changes are. This builds intuition no single tutorial can give you. It's like having a real job experience. Surveys also teach you how to read papers efficiently and critically, instead of passively copying ideas. You're not aiming to invent something new, you're learning how the field thinks. That intuition carries directly into interviews and real ML work. This never stops. ML is not a closed discipline. Knowledge from other areas often becomes your unfair advantage. For example, graph theory helps you with recommender systems, 3D geometry helps with robotics and vision, video processing helps with temporal models, system architecture design skills help you train faster and cheaper. The broader your toolbox, the fewer problems look impossible.